I've recently added Turtle Graphics to Foam, and I'd like to show you how it works. So I'm using the flow shell, and a turtle is a type of object, so I can drop one to the canvas. Now, because it's an object, I can have more than one. Okay, and then I can take one, forward 100, right 90, or I can do turtle 2, back 200, 2. Okay. So you have all the standard turtle graphic commands. So turtle graphics originally come from the programming language Logo, and you have things like forward, back, left, right, set the pen colors, maybe set the pen width, go home, clear the screen, and so on and so forth. Or I'll create a script object to make it easier to program. Let's say forward 100 and then right 90. If I run this 4 times, I get a square, which I could inside a repeat or for loop. Okay, that gives me the square in one pass. After that, I'll turn right 10. I keep running this, then I'll get this pattern, which of course I could have put in a loop as well. And that's a very standard kind of program to made in Logo or with Turtle Graphics. But we can do other things as well. So here is a kind of a standard Logo program. I've just converted directly to Foam Turtle Graphics. It gives us this nice pattern. And I'm just setting the color to this hue, saturation, lightness level at each step. Here's another kind of standard Logo program. So you have one loop to draw each circle, and then you rotate a little bit and then draw the next circle. And again, I'm cycling the colors. Another one. Okay, here's a standard recursive fern. I create a function. This is just standard JavaScript to create a fern using a given turtle of a particular size. And this is, I just draw a fern. I draw the stem, then I draw the fern on the left, the fern on the right, and then the tail is a fern as well. And I just make them smaller. What I could also do, so I have save state and restore state. That makes a lot of kind of graphics programming easier. What I could have also done, I'll make a for much less detail. I could spawn a new turtle. So I could say turtle equals turtle dot spawn, and that'll create a new one. And here I can say turtle dot die. And if we had an animation, you would see the turtle spawn into two turtles, and then it would go off in parallel to teach parallelism. But let's not kill the turtle. Let's run this. Now we see all the turtles just at their end of their job. So here's another program. And what the turtle's doing here, it's using the lay command. So we've created a new object, a new circle, and then as this turtle moves around, we're laying those objects at that particular spot. So it's not just a comparative graphics. Everything that you create, even lines, are objects which are added to the canvas. And then you can do all the things with those that you could subsequently do with regular objects. So here we can turn on physics, gravity, and they all fall down. So not just creating static images. So here we create some objects, and then we use Foam's reactive programming to animate them. So again, because they're real objects, they can have life of their own after you create them. Here we create a tree. It's similar to the fern. That's a recursive function. And I lay some circles to represent leaves on the ends of the branches. Go to physics, watch them blossom, and then we turn on gravity in the fall. Here's a little recursive Sierpinski triangle. Then I created a Sierpinski pentagon, and then create 7 of them in rotation, which creates a nice pattern. Here's the same thing, just have some for loops, move around, and add circles. Here we just rotate around, create this pattern, lots of lines. It looks pretty nice. Another variation, similar to one we saw earlier. So here we can see we've got this color burst. It's a very short program. Here, we're using some trigonometry, getting this kind of wave function. You can see the lines. But if we increase the density a lot, then it looks like we have a solid surface. But all we're doing is turtle graphics and line commands. This one is similar to the fern, and that's recursive function, but I've used it to create a dragon. So this is basically the spine of the fern, the tail and the neck, as are each wing, and then the feathers. And here's another variation. We just have this one fractal function, and then we call it with different parameters for the tail, the body, the wings, and the head. Here we've started at sort of the basics of 3D graphics, and what we want to add more is, instead of just moving left and right, that the turtle can like pitch and roll and move through 3D space, and then be able to see that stereoscopically. Okay, using like something like a Google Cardboard. So the differences between regular turtle graphics is that the turtles are themselves just objects, and you're programming in JavaScript. So it's object oriented, and you can have multiple turtles. Turtles can spawn and die new turtles to do parallelism. They can lay objects, and those objects can work with Foam's reactive programming or physics engine. And we have some support for 3D graphics as well. So it's available on the one website. Give it a try.